Good afternoon and welcome to this NZIOB webinar on the Waikato River to Redoubt project, or RTR. My name is Malcolm Fleming. I'm the Chief Executive of the NZIOB. Today's webinar is a result of one of the speakers, Fazim Fazadi, winning the Supreme Award at the 2021 New Zealand Building Industry Awards. What was noteworthy about that accomplishment was that Fazim was the first person to go on, after winning the innovation category of the awards, to go on to winning the Supreme Award, which was the first ever. The Supreme Award at those awards is traditionally won by a project category winner. The citation back in August at the awards included the following commentary: the digital delivery process that Fazim Fazadi brought to the Waikato River to Redoubt water supply program fast-tracked the project design and compressed a 3-year design and build into 1 year, which is unprecedented. His bespoke software cut through thousands of design hours. One judge added that he had never seen an individual contribution and passion such as he'd witnessed with Fazim on this project. So Fazim's winning of the Supreme Award at the New Zealand Building Industry Awards created a great deal of interest from our members who are very keen to understand what it was about the innovative process that Fazim was credited with producing and how it was implemented on the F2R project. So Fazim is an associate at Becker and also an NZIOB member, and sharing the speaking duties today is Water Care Program Manager Sven Halos. The two of them in combination provide perspectives on the innovation that was produced and on the project itself from both the client and from a consultant perspective. So according to Hannah, who organises these logistics for the NZIOB webinars, Fazim and Sven have been the most organised presenters that we've had in the last couple of years. So she's never seen such high level of efficiency, which was obviously part of the what made the RTR project so successful, and it's obviously flowing through to Sven and Fazim's day-to-day business dealings also. So they've been a pleasure to deal with. So I'll now hand over to Fazim and to Sven, and I'll rejoin webinars for question time. So in the meantime, just use the Q&A box on the webinar software, and I'll come back about 5 minutes to or 10 minutes to 6, and we'll close out promptly at 6 after I facilitate the questions. Welcome, Fazim and Sven.
Thank you, Malcolm, and I hope we can keep it going without a hitch. Here it is, something still, we trained a bit in the last few months on online presentations and online video conferencing, but let's get into it. And I have the pleasure today to introduce the digital engineering presentation with just some background on the project and also on the wider perspective, how we set out for this work and how we got there at the end and what been the special moments and also the special tools we used to make this program successful and get Auckland the water what it desperately needed. Maybe also to say that, what we achieved in 12 months could be a bit of a blueprint for accelerated infrastructure delivery in New Zealand with an infrastructure gap sure everyone is aware of. And in the next few decades, we surely need to develop different solutions to deliver infrastructure in New Zealand more efficiently and with the sustainable environmental footprint as well. And digital engineering is clearly one of the main tools to go for it and to be at the core of success for the future. Maybe the next slide, Fazan, please, if you could. So starting off, maybe as an overview, Water Care is the water and wastewater provider for the greater Auckland region. That means it's about 2 million customers, and we reach from kind of Pocono in the south of Auckland to up to Wellsford and provide everything from the dams to the customers tap water, and then also take the wastewater away and treat it before it's released into the environment. That's water care in a short, and where the whole program was based on is our enterprise model. That is the way we deliver infrastructure over the next 10 years. It's about $8 billion in our asset management plan, what we have to deliver to keep Auckland's water and wastewater services running and keep up with population growth, renewal, and also better levels of service. How we achieve this is we have partnered with two construction companies. One is Fletcher Construction, the other one is Fulton Hogan, and they share with us early contract involvement, and we partner with them over the whole construction delivery. As I said, $8 billion over the next 10 years on a journey. This program, the water care or the Waikato River to Redart program, was one of the first in a series of, yeah, let's start the there, Fasan. Okay, you got a bit fast, but that's fine. So what we have built is a floating pump station in the Waikato River to take water out of the river with 4 pumps and screens to avoid fishes and other particles to suck in. What you see here is the existing raw water pump station and an overland pipeline, what we have constructed to save carbon, to dig it in, but also to save construction time, mainly to be able to build it in 1 year. That's a 700 PE pipeline going up the hill. And what you see here is the construction platform where the treatment plant was established. Treatment technologies we have used is membrane ultrafiltration technology on the right, some chemical systems, as you see here in the back, with some blowers, and followed by granular activated carbon filtration. At the bottom, we established a chlorine contact tank and a treated water tank and a big pump station, as you see here, to boost the water into Auckland's supply. We had to connect to an existing water main, a 1200 steel water main, what was achieved during a large shutdown last Christmas, where we could shut down the existing plant. And then that's a 30-kilometer journey into supply. We needed a boost pump station in Papakura because the pipeline can only take 175 megaliter a day. We boost another 50. That means we needed a boost pump station to be able to boost the water up to the reservoirs again from a gravity supply, after the initial pumping out of the treatment plant. So very large pumps, 3 meter high, being established here. And maybe back to the presentation, Farzan. And yes, maybe hang on to this one a little bit. So what we have is, as I said, an intake in the Waikato River, pipeline up into a raw water reservoir or tank, the treatment plant, and then a pipeline what runs over an existing reservoir at Ransman Road, the boost pump station in Papakura into Redart and then into the city. We supplying from these reservoirs really up to Oriwa at the north shore of Auckland water, as well as out west and everywhere in town. So a very large supply area from a large reservoir complex. About the program and the challenge and why it was all needed and why we need to do it in 12 months. Our water, you will be aware that there was a severe drought in Auckland over the last 2 years. Dam levels have dropped below 40%, and we would have been able to construct the plant in a short time. There was a high risk we could run out of more severe water, but also we would have to put severe restrictions in for Auckland's industry and for the people of Auckland, what we tried to avoid by all means. So another treatment plant, other sources online being the only way to augment the growing city. Auckland grows by 50,000 people every year, and we have to keep up with our supply and also get more and more drought resilient. So the treatment plant, what we have established, called Waikato 50 as part of the future larger Waikato treatment plant, what is the moment at the board of inquiry to take a little bit more water for the last time out of the Waikato River before we have to look at alternative supply sources in the future. Can you go to the next one, please, Farzan? Let's talk about the team. So we had a challenge. We had to do things clearly differently than a normal program delivery of this size. And what we're talking here is about 50 megaliters a day. That is equal to the water supply of, let's say, Tauranga and Hamilton together, to give you a perspective. So we had to really pull out all stops and establish a experienced team, get early supplier integration, get early contractor integration, and all work together very collaborative from the beginning with water care, taking the risk on a commercial model as well, what worked to enable us to construct and design in parallel, and then start also commissioning while we're still constructing, to be able to achieve really to design, consent, procure, build and commission a water treatment plant of reasonable size of 50 megaliter within 1 year. Next one, please. Talked a lot about collaboration and no blame culture. So we all had co-location at the Becker headquarters, where we all work together on a day-to-day basis, established teams, had daily sprints, daily stand-up, agile delivery methods. We established trust with each other. We had clearly a no-blame culture, that we've been allowed to make mistakes, move on, and focused really on the outcome at the end, that we have to get water on by June 21. Our other objectives being, we want to get everyone home safely. We wanted to have minimal interruption of the existing water treatment plant. There's no point in interrupting the existing plant producing water for Auckland at full peak capacity. So we had tried to minimize any shutdowns of the existing plant. And also we wanted to protect the health and the well-being of the Waikato River as our commitment to the stakeholders. Meaning that we had to use different methods. We had to use offsite manufacturing, but also as one of the core things, we had to use digital collaboration. And Farzan will soon talk much more about it. But digital collaboration wasn't only used in the design space, it was clearly used for stakeholder management. We had our board on the virtual reality 3D goggles, where we had this 3D model all presented. We had our operators and maintenance staff walking through the virtual plant to identify the clashes and any problems with future maintenance and operations activities. We used it for construction rehearsals, but I'm sure Farzan will talk much more about the digital world, where we dived all into. So I hand over to Farzan to continue. Please, Farzan.
Thanks, Stefan, and here everyone. Really appreciate your time and this opportunity. And during next 30 or 20 minutes, I'm going to share some of challenges, some of the innovations that the team that work on R2R developed and implemented, and that resulted in outstanding facilities which developed for Auckland. Speaking of digital collaboration and digital engineering, and at the start of the project, I remember we had some objectives at program level that we wanted to achieve. And the main one was the agile nature of this program. We needed to, as Stephen mentioned, design, construct, and commission 5 facilities within 12 months timeframe. But at the same time, as part of enterprise model, it was our objectives to reduce overall cost of the program, reduce carbon footprint of our exercises, and we had a specific focus on health and safety. We wanted to, no matter what we do, we wanted to have consistent outcomes. And at the same time, we wanted to empower prefabrication and digital construction to be able to achieve what we needed to achieve. And the data that we wanted to develop, it was important that we can provide data that can be used for asset management and facility management. And all these objectives took us to a point that we start thinking about that how a data-driven mindset and process-focused approaches can create the difference. The goal was quite a simple one. We needed to go from what you can see in the plan that we had at the start of the project on the left side of your screen to the image that you can see on the right side of the screen within a year. That was literally a challenge and game, and we identified that digital engineering can be a tool, can be a process that can help us to achieve the required outcomes. We had a really agile and I can say young team that they were really keen about identifying a new way of working. And as I said, we identified requirements, and one of the main one was for us was that being agile and being as fast as possible. In aviation terms, I can say that approach was that we wanted to take off as soon as possible, while we were still working on developing and building and fixing our plane. And the objectives that we had was that we wanted to be a data-focused team, and that pushed us to culture of collaboration with a specific focus on digital. And the tool that we identified was that the digital processes can help us to develop strategies that can achieve and help us to achieve outcomes. As I said, the objectives was development of a new processes, but at the same time being agile and being fast. That create a risk, that create a unique challenge, but we came across really good exercises and good experiences that later on I will share at the end of my presentation. While we wanted to develop our processes and solutions. And the good approach about it is that in the digital and in the software engineering field, we always have a 3 sprint of development. And what does it mean is that if we develop if we want to develop a new process, first we need to identify requirements. We need to make a plan of action, and we need to design our processes and specific steps in that process. And then we need to develop a tool or set of tools that help us to achieve the outcomes. We need to test them, deploy them, review them, and then launch them. And after that step is still when we share a new process, we are going to test it actually on a specific jobs or projects. And we identified errors, we identify challenges that we need to improve them again. And literally in a software engineering, always we have that 3 steps of improvement, but on R2R, and that agile nature of it pushed us to the point that we simply had 1 sprint of development, and we identified requirements and we tried to be as agile as possible, identify the ways that we can work differently, develop a process and launch that process. And speaking of processes, during this webinar, I'm going to share with you 7 things that we did differently on R2R program. One will be about talking about geospatial system and importance of it, and that the second one will be about automated daily digital collaboration that resulted in digital verification and digital construction. I'm going to touch base on sustainability and how digital engineering can improve sustainability, and the last 2 piece will be asset data mapping and capturing and facility twin. Step 1 for our program was we needed to create a specific geospatial system that can support different design authoring tools. R2R program, we had about 80 design tools that developed with the different design teams and modeling teams across the country and overseas. We are 8 different design authoring tools. And as I'm sure most of you are aware of, some of our design tools in industry, like Revit, has 3 specific coordinate system, and some of the other tools, like as an example, 12D or E3D, has a vote coordinate system, which is just purely one single type of geospatial system. And for us was important because we had a limited time. We wanted to make sure we can collaborate as fast as possible, and we didn't have any time for manual exercises. We needed to have a system that no matter who designed a file, no matter what design authoring tools they used, the data, which contains both graphical and 3D element, and also the information and metadata, can be collaborated within a one single source of truth. And that was at the start of the project that we spent about 2 weeks to identify different and test different solutions. And I remember it was a Saturday late evening, about 10 p.m. that we finally found a solution. And that moment, I can say it was an absolute joy, and I was lucky enough to have a couple of moments like that as well during the construction phase of this unique program. The second step for us that after we identified and ticked that first box, the second thing that and the process that we tried to innovate was that how we can automate process of sharing data. And as I said, we had about 80 design models developed with the different designers, and we have approximately about 400 people that just purely work from BECA, combination of designers, engineers, planners, that they were responsible for creation of information. And for us was important that how we want to share a great number of data within a short period of time. We are on approximately 80 to 90% of our design completed within 4 months, but from day one, we shared what we developed, what we had with our construction partners, with our design partners, and high level of transparency was important to achieve outcomes of the program. The second goal that we had was develop a process that can think, that can work, and can share all the data without manual input, no matter what type of information or model we are talking about, or who is responsible to develop them. We set up a process that during the 12 months timeframe of the design and construction phase of the program shared design models more than 300 times. Imagine if you are working on the design of the project and you have a set of drawings. Traditional way of working is that we have 4 or 5 different stages. At the end of each stage, we share our information. Imagine, and that is maximum 5 times. Imagine if you needed to do it more than 300 times. And the cost associated to that exercise also could be significant. The process that we developed for R2R program was simply a process that machine, an algorithm, and steps that machine could think, could share, and could automate that process. During 12 months, every single design models and data shared from 11 p.m. till 6 a.m. And no matter, as an example, what a structural team or mechanical team developed during the day was visible for construction teams next day at 8 a.m. This process, and if we had 80 design models, and I'm going to run a quick math for you, if we have about 80 design models as an example that needs to be shared, and if we just want to spend 2 minutes per each drawing, per each model, which is it purely a time that you can open a file almost often, it's just the 2 minutes. And if you need to share it more than 300, 330 times, within 12 months time frame, we are talking about beyond 1,000 hours worth of effort just purely for sharing data. By automating this process, we not just approximately saved about 200K worth of effort, we saved about 1,000 hours worth of effort that could spend on other side of the project, and we needed resources to support delivery of the program. The third steps for us that create that literally it started with a risk that we identified, and that risk was that when on the left side of your screen you can see two snapshot from our digital environment that we used for visual collaboration, and when we had that capability to share this information with our construction partners and they started using them for construction exercises, the construction activities on site on this program started at the same time that we start designing. And when the project development was in such a pace, the risk was that how we want to make sure that the data that we are sharing with construction teams are ready for construction. How we can make sure that when we finalized and review just half of our design models, and the other half is not ready. And as an example, in a scenario, if we have 2 pumps next to each other or 2 columns next to each other, if one of them is reviewed and another one is still work in progress, how we want to share that message with construction team and with other parties, with Watercare project management team, with our design partners across the country to just understand what is ready for fabrication or construction and what is still work in progress. We learned that simplicity and practicality are keys to implement new ways of working, and that's what we did at this step. We developed a simple parametric approach that on top and is top right corner of your screen, what you see is a design authoring tool that design teams were using for design. And it was literally a parameter that we could import to our models after we reviewed it. And next day, when this information is shared with our design and construction partners, on bottom right corner, you can see a snapshot that color coded as simply as 3 colors. Green means ready to be built. Orange means it's still in progress, but almost close for to be finalized. At red means at the start of design. And we are a simple way we could share that message without requirement to sending emails, sending notifications, or calling them, or need to have a meeting to have 100 people to attend to that meeting to share those informations. And that data could be updated on daily basis. By being able to share verified and reviewed the data that we needed, we simply took the next step after we had a really productive collaborations with our construction teams from Felice and Fulton Hagen, and we simply empowered digital construction for the program. We had the data that we could use for prefabrication, for the construction, and we could use tools like machine controls on site. The data could be extracted from design models, and machines could decide and read the data without any specific input from resources, and could decide, as an example, the depth of excavation, angle of excavation, the height of excavation, and that had significant impact on minimizing machineries on site, and consequently carbon footprint of our operation. The top left corner is a snapshot of when we did our excavation, and when we did our excavation and when we scanned the entire that area of work, and we compared it against what built on site, and the tolerance was approximately within 10 millimeter, which is significant for earthwork, and that was what built for subcontractors, and they could start the foundation works on an environment which was well excavated and was ready for next stage of construction. The next one in my list that I want to share with you today is how digital engineering have impact on sustainability. And the way that I experienced it on this program was how transparency have empowered sustainability. On this program, we shared our data with Watercare, with the construction teams, and literally it was a single source of truth, a digital hub that all data federated and shared in that environment. They could review our design, and they could review it from sustainability perspective, and they could have effective feedback on the materials that we proposed, on equipments that we selected, and they could review it and provide feedback to see how we can make sure we can select the best materials, we can select the best equipments to meet sustainability objectives of the program. And that transparency simply empowered us to make sure that we can meet those requirements. At the same time, by being able to share this information with construction teams, we could share it with subcontractors and site as well, and our construction team literally could start walking to the project even and before even construction started, and that simply helped to minimize rework and minimize variation. And if we can minimize challenges and variations and reworks on site, simply we save material. We are going to use less resources on site. We will need less machineries on site, and consequently, we are going to have positive impact on overall sustainability approaches and requirements. The sixth step for us was we started to think about how we can capture asset data for asset management and facility management from our design models that, as I said, developed via different design authoring tools. And we had a simple challenge here. And that simple challenge, I believe, is applicable in a vertical sector and specifically for building services design as well. And that is that simply how we can define an asset. As an example, if we have a pipeline that contains multiple valves, contains multiple pipes, contains multiple elbows, those elements will be individual elements in 3D environment, in a digital environment. But from asset perspective, all the entire pipeline, as an example, can be defined as just purely one asset. And our challenge was that how we can create a mapping system that when we needed data, some data like equipment numbers, like pipeline numbers, like tag numbers, that we can extract from design models, how we can do it while we are still meeting asset data requirement and classification systems that developed for the program. And that pushed us to utilize different processes, different platforms, and create a new way of capturing and mapping data, and it helped us to simply create a smart way that if we can populate information and capture information for a entire pipeline, that can, in asset management system, it will still be one asset, but when we publish those data and want to host those informations in 3D environment, Each individual element in 3D space can host data, and that will be a significant game changer, I believe, when our operation team, as an example, it's at 2 a.m. and they need to have access to some information, and they don't need to go through sheets of spreadsheets or files. They can simply open their digital asset management platform. They can select and that a specific element and find all the data that they need that can help them with asset decision-making exercises. The step 7 for us was that we implemented for one of facilities that developed as part of R2R program was a facility twin platform. And simply that facility twin is a platform that can behaves, can looks, and like an actual facility, an actual and represent actual assets, but at the same time, it connected to the live and real world. It connected to the data that will be updated during different stages. And simply in this platform, our team worked with Watercare and with our construction partners and design partners. And simply we created a platform that can host 3D information, can host 2D information, can host documents such as classification, and also categorized, as you can see on the top right corner of your screen, as per each asset level. And that's defined based on the asset classification system that we had for program. And it's simply, you can walk through the program, walk through an asset and a facility, but at the same time, you will have access to the drawings, PNIDs, and the data that captured and populated for that specific asset. And we, as I said, we developed a platform for one of these facilities as a new way of looking at the asset management platforms and how this type of mindset can help improving productivity and also helping to share right data to right people at right time. And so all these 7 things were part of what the team did and created for R2R program. But always wasn't just a fun part. We definitely had challenges. The project was one of the most interesting projects that I had always the fortune to be as part of. But at the same time, we had challenges, and that challenges pushed us to think outside the box and to come up with the new solution. And if I want to categorize them, I can break it down to 2 different parts. The first one, which was the primary for me and for our team, was the cultural change. We had more than 2,500 people worked for the program, but at the same time, we had, as I said, about 400 people that had input and had impact on creation of information. And that was a significant challenge because on R2R program, we established a data-driven mindset at the start of the program. And we, all of us, no matter which company we were part of, we committed to it. But all of us, we had the challenge that for a great number of years, we used to review, develop drawings, review them, verify them, issue them. And for a facility like that, we needed to maybe having 2,000 to 3,000 to 4,000 number of drawings. It was challenging for us to reduce those number of drawings, to be able to reduce the design phase, but at the same time, be able to provide same level of information within digital format. That create a significant challenge for us, but that learning curve, I believe, for all of us was very fantastic. And we hope what we learned on R2R program can implement it on our future projects, no matter what sector we will be involved. The second one was technological challenge. We had, as I said earlier during this presentation, we had about 80 design models developed via different design authoring tools. And we needed to share and collaborate them more than 300 times. It wasn't just purely 3D objects. It was data that need to be shared. And we are talking about million cells of information, and how be able to map this information, how be able to transfer a file from one format to a different format, while we still needed to make sure that all the data are still contained and that a specific file is rich enough for construction, was a significant challenge. And we kind of mitigate the risks and challenges that we had via the kind of the 7 steps that I shared with you previously. Main lesson learned for me personally, I'm in construction industry for about 15 years, had the opportunity to work in 3 different continents and in a different segments. And I can say during the last 10 years, the focus of my career was just purely on digital side delivery and implementation. And I learned 4 simple facts that I believe are keys to a successful digital transformation. The first one for me is transparency and delegation. We should understand that without being fully transparent with respect to challenges, risks, with our construction partners, with our design partners, and without wanting to share those challenges and risks, we cannot innovate a new way of team working. By having barriers and boundaries and developing clear responsibilities and creating walls around us to protect us from risk, simply we will kill the mindset of innovation. We should mitigate control and ranking. We should empower young generation in construction industry to have input, because a simple example on R2R, I had the fortune to work with the 3 young professionals that had a significant impact on what we developed and did on R2R program. And we should empower them, and we shouldn't rank people with the number of years that they have in their CV for experience. I learned that young generation can have significant impact on developing and working and doing things differently. R2R, the third one, R2R is a great example of agile nature. Construction industry, we do so much planning and we do less action and so little action. And agile action, but with the understanding that we will need continuous iteration, is a way to innovate and promote and empower productivity and efficiency in construction. And the last one for me, we shouldn't have a fear of risk. We should culture of risk taking and empowering collaboration. And because of that, it will push us to think differently, work differently, and consequently create a different result. And another, what I want to say, I'm a generation that I remember when first time I came across a name called Steve Jobs. And one of the things that I hugely admire about him is that he always believed that technology is not important. What is important is that we need to have faith in people. And that's an absolute goal that I always follow in my career. And what I learned from it is that by empowering people and by going through those cultural changes, we can create a difference. And now, Stefan, I'm going to hand over to you for other part of the presentation about our outcomes.
Thank you, Farzan. Thanks very much. And I fully agree. I think on this project, we had both. We had fantastic people and the right people at the right time and with the right expertise, but we had also fantastic technology. And I think both things together made this program very, very successful. What you see here, maybe on the bottom left, you see the picture of where the treatment plant supposed to be built in August 2020, and we had barely just felled the pine forest trees to be able to establish a platform for the treatment plant. And then 10 months later, there was a fully commissioned, fully functional water treatment plant for 300,000 people. all to drinking water standards and best water quality out of the Waikato River. You can see here in the background with the existing plant also in the background. So that's most probably Farzan. Can I have the next slide, please? Gives me time to sum up, and looks like I have still a few minutes to sum up the outcomes and the main points we would like to make. So for instance, a program this size would normally take a year to design, then you need to consent it, then you need to tender it, and then you need to construct it for 2 years and then commission it. So it is at least a 3 to 4 year build under normal design and construct timeframes. And we managed to all condense this into 1 year. Very great outcome. We managed to save also at least $10 million with reduced overheads by condensing the program into this 1 year. We, as Farzan mentioned before, had much less rework. And it's the first time I worked really truly off a 3D model and designed and built and collaborated and worked also with our operations team on a 3D model with much reduced drawings. We had, I think, reduced our drawings. We still had some electrical drawings for electricians. They seems not to be able to live without their drawings and loop diagrams, but we had 60% less drawings on this job and worked really the first time truly of a 3D model also into construction and machine controls. Collaboration in 3D space. It was great to have everyone in the office, and it was even better to have people from overseas and from other offices be able to collaborate on a daily federated and updated model, and also on site seeing what has been done off-site at the design office the next day on site to be able to build. We had the right people on site to answer questions. We had the people with the right experience on site to answer questions, to resolve construction issues in a short time frame, to be able to maintain our 12 months build overall objective. And we had a great impact on the environment also with reduced waste, with the ability out of the 3D model to construct erosion sediment control plans out of the 3D world. We could avoid over excavation to do out of the digital model. So in summary, before I finish off here, we had to balance innovation and proven technologies. We didn't have the time to invent a total new way of treating the water. We used most of the technologies established 20 years ago and been proven over 20 years. But we had some innovation with spiral welded tanks on site, what has been done before only in a workshop. We really harnessed the early procurement of major equipment items, what enabled us to design then around it. We had, as I said, subject matter experts, and that's a quite important point, to be able to make fast decisions and make decisions on the spot. And we've been able to move on and not had large multi-criteria analysis workshops. We had the right people there to make the decisions. We made the decisions and we moved on in the design and selected the equipment what we needed. And we had a good balance as well out of off-site manufacturing and on-site manufacturing, what enabled us more to do a industrial manufacturing style construction by bringing in pre-assembled components onto site to avoid to have even more people than 350 working all over each other on what was a very condensed site. In this regard, I want to thank everyone involved in this program and who was making this program a great success, and also thank NZIOB, and we open for questions. I believe I give back to Malcolm.
That's great. Thank you very much, Sven and Farzan. I'm getting a real sense here of the main driver for this whole project was water capacity, or the capacity of Auckland Water, and that there was an imperative to increase water supply, in particular with coming droughts or the regularity of droughts. So there's a real feeling here, necessity of the mother of invention going on in terms of we need water supply. We need to undertake a different approach to how we can get water to Auckland as quickly as possible with a brand new project. I also picked up on there that this was like the last opportunity to draw from the Waikato River. Did I pick that up in the presentation somewhere?
That's correct. I think Watercare made the choice that there is at the moment the last application in to draw water from the Waikato River. It's another 150 million liters, and this plant, what we just have built, is the first part of it. So it will be expanded to an ultimate capacity if that gets granted by the Environment Court. What is at session at the moment in Hamilton, then we will,
So there's a real
use this
there.
plant the last time, and then in future we have to look really at other alternative water sources, be it desalination or reuse or whatever is socially acceptable.
Okay. So a couple of things that came to me. I like the plane analogy that you came up with there, Farzan, that you're wanting to take off in the plane, but you're still developing the plane. So what's some of the examples of that?
As an example, the clear example of that, it will be that a data capturing platform that I shared with you and the process that I shared with you. That was the first time that we wanted to implement an approach like that for water sector, and the development of data via different tools. It was really challenging. We learned that there are some design altering tools that they are not smart enough to be able to share data or to be able to host data. And at the same time, there are like platforms that arguably in industry debate, like IFC files. We always told that IFC files can be a unique type of file that you can kind of like convert, you can import and you can export, and that can host data. But unfortunately, when you put it in practice, you will identify that there are issues with this type of a specific file, and you cannot always be rely on them. So that technological piece, it was what we what I can say, it was like a plane that we were trying to fix while we were flying.
So that geospatial system that you developed, and that's what you're acknowledged for in the New Zealand Building Industry Awards. What I'm really interested in, most of the members who'll be watching this live or watching the video later on, was what's the ability to replicate it and utilise that model in both in the vertical space? And have there been examples of it actually being undertaken like now?
If I want to answer that, I think in a vertical space, actually it's a lot easier because vertical sector is a lot more mature, and the number of our designed authoring tools also is not as diverse at infrastructure or water sectors. And currently, we can implement a system that the shared data without that much challenges, but as an example, we have the same scenarios when we are using a tools for like a 12D for a development of civil information. Even in vertical space, there are some issues about it that via this way of working, we can make sure that the data can be shared without any issue and in an efficient manner.
I just want to touch on a couple other things and then we'll get to the questions. So we've got a few questions lining up, which is great. It was touched on in your presentation about the use of digital construction tools, excavators connected to the computer model. So I'm interested in how tech ready was the contractor in that regard, and were some of the, you showed an excavator example. Are those excavator and other machinery, were they run autonomously at all, or were they still needing a driver?
Yeah, so I can put it in that way. When we want to do excavation on site, on this job, what I heard from construction teams, they had two different areas that they need to do. And to test that for one area, they used the machine controls. And on the second area, they did it in the normal way that we are working, that you need to have a surveyor to work with the operator and to highlight the depths, angles, and the distance and the area of excavation. But for machine controls, literally all those data can be imported, and via GPS systems and coordinate system, then your machine and just one operator within a machine, just purely to make sure that the machine operates without any issue, can deliver the outcome. And you just not just save resources to do the job, you will save time because you can excavate more efficiently and you can excavate not beyond requirements. And by doing that, you will reduce the carbon footprint of your excavations as well.
Right, I'm going to dive into this this list of questions that we've got here, which is good. Farzan, I'm interested to understand why Omni-class was specified over Uni-class 2015 for asset codes.
Yeah, so for this job, we used Omni-class classification number. And we then utilize a Uni-class for this job because it was matching more with Watercare asset management system. And that classification system at the end of the day does not create that much difference. It's just in a way that you can create a hierarchy for your data. But it was important for us that at the start of the project and commencement of the project, we had the opportunity to work really closely with Watercare digital engineering team to address this query and come up with the solution with regard to asset data schema and classification system that we needed to follow for the program.
There's a couple of questions here on the same subject, which is the digital twin and asset management. It was one of the questions I was going to ask. So there's a couple here. I'll just try and sort of weave them together. So was the digital twin platform, was it purpose built for this project? I presume it was, as opposed to being off the shelf platform. So that's one part of the question. And that digital platform, whether it was bespoke or off the shelf, how is it being utilised by the FM?
Yeah, so that facility twin platform is the platform that Becca started to develop from a couple of years ago, and one of the uniqueness that about this program is that it can be utilized per each project for each sector or for each specific type of assets, so that development of that job. The start of that, an important part of that was that we worked closely with the construction teams and Watercare to be able to understand those requirements, to be able to understand what asset data needs to be captured and how we can share those information within facility twin environment and the file, the platform for that one facility that I highlighted shared with Watercare. And it's ready to be used as a proof of concept of how one digital solution, one digital platform can kind of like looks like a real facility, can contains data, not just 3D data, the 2D informations, PNIDs, drawings, and how all these data and informations can be connected and linked with each other in a smart manner with respect to the asset data schema of the program.
There's a question here, are we using the same collaborative digital design process and softwares on further projects with other clients? Which we touched on before.
Yes, and it's not in a water sector anymore, and we implemented on some of our transport projects as well, which is it's really great to see that mindset of we need to focus on data more and more is not important to our industry design or construction teams anymore. It's become a really an approach that our clients identified as a goal, and they want to take that journey and achieve a level that can host and create a data that can be used and recycled during life cycle of their assets.
1 minute left. One final question. It's a really good sort of catch-all from the attendees. What improvements or changes would you make to the process if you were starting again?
That's a very good question. And always when I do something, even when my wife and I, we go to a restaurant, we always rate that dish. Or when I do a work at the end of each project, I give myself a number, I give myself a mark. And I'm quite honest when I tell you that I give myself 6 out of 10. There are heaps that need to be improved, and all those 7 steps that I shared with you, when we are started to doing on a new jobs, they require significant improvement. And that's the exciting thing about our industry. There are heaps that need to be improved.
That's great. That brings us to a close bang on 6 o'clock, and I'm militant of the timekeeping. It's been a joy, Farzan and Sven, to have you both, and thank you for sharing. NZIOB members, you'll be able to access this video off your dashboards to watch at your leisure. So thank you for your attendance, and that concludes our presentation. Thanks once again, Sven and Farzan.
Thank you.
Thank you, everyone. That was for the opportunity to be able to talk, and thanks the whole team for making this all possible, and thanks NZIOB, for this evening presentation. Bye-bye.